Okay, in the previous lecture, we have discussed very detailed about the pointer and references of derived class and how can we use a pointer and a reference of derived class to access a derived class member function. Thereafter, we have discussed in detail about how can we use a base pointer and reference to access derived method. Okay, and we have found that there is few limitations that a base pointer cannot access any method from the derived class object, but it can access the method from the base part of the derived class object. And at last of the previous lecture, I have introduced a solution to this problem that we called the virtual function. Okay, so this is the solution that I have introduced in the previous lecture when we derive two class, a cat and a dog from the animal class, and we found that whenever we use a pointer of animal class, we are unable to call the speak method from cat, unable to call speak method from dog, rather it's called the speak method from animal. So in this lecture, we're going to see how virtual function can be designed and how virtual function will help us to achieve our goal. So this lecture content was totally depend based on the virtual function, and this is one of the way that we can achieve polymorphism in C++. So let's first try to understand what do you mean by a virtual function. We called it is a special type of function and called for what purpose? To resolve the most derived version of the function that exists between the base and derived class. It is called a special function. Okay, and this virtual function will help us to call what? To call most derived version of what? Of a function that available in between the base and derived class. What is the meaning of this definition? Suppose let's consider a hierarchy. We have a class A as a topmost base class. Then we inherit a class B from class A. Thereafter, we inherit another class C from B. This is what? Very familiar. We know this is an example of multi-level inheritance in which a derived class can act as a base class to another derived class. Now, suppose that class A has one function f1. Similarly, class B also have a same function called f1 and class C also have a same function called f2. Sorry, f1. So what this definition tells us? This definition tells us if we declare the f1 of A as virtual, okay, I repeat again, if we declare f1 as virtual to class A, then using class A pointer or reference, we can call a method from either B or either C. Okay, so this is the line written here. It tells us that it resolves what? It resolves to call a function which is available in base and derived class. Okay, so this is the facility of a virtual class. So what we should do? We should declare a function inside the topmost base class as virtual. Okay, this mechanism of using virtual function is also known as polymorphism. Look at this diagram again. Class A has a function called f1 and B is derived from A and C is derived from B. All these three classes have a function called f1 in common in all these three classes. So can we say it is a function with same name in three different classes and having various forms? Okay. So what is polymorphism that we already discussed during our course? Poly means multiple, morphism means one name, multiple form. Okay. So here f1 is what? f1 is the name of the function, should be remain same in all the three classes. This capability is called polymorphism by declaring f1 in A as virtual. A function is considered a match if it has the same signature. So means be careful about this third point. It means what? Suppose we have two classes here, A further derived to B. If we want to support polymorphism using virtual function in these two classes, then we should remember this point which is very important. Think that the same signature we should use. What is the meaning of signature? The meaning of signature means the name of the function, the parameters type, and function is constant or not, and return time are called the signature, and this signature should be remain same in A as well as in B. Means suppose A had a function called f and it has one argument of type int, and return type of the function is suppose void. So if I want this function as virtual, okay, and we need to support polymorphism, then what should we do? We should define the same function in B also. Name of the function in B should be remain same as f. The argument type is also remain same as int, and return type is also should be remain same as void. So this is the thing that I mentioned, the signature of the function should be remain same. Whereas in function overloading, we know that signature of the function, name of the function will remain same except its list of argument and type of argument and order of the argument. But here everything should be matched same. Fourth point, such functions are called overrides. So this mechanism of polymorphism is called function overriding, and previously we discussed about function overloading. Okay, in function overloading, type of the argument or number of the argument or order of the argument should be varies, but in overriding it should be remain same in two different classes, in base or in derived. Remember one more point, function overriding is possible within a class only. Sorry, I repeat again. Function overloading is possible within a class only. Okay, within a class, not more than one class, but function overriding is possible in a multiple class. Okay, so to support function overriding, we first do inheritance, but to do function overloading, inheritance is not required. To make a function virtual, what to do? We simply going to put the virtual keyword before the function declaration. Very easy to make a function virtual. Just use the virtual keyword before the function declaration. So this is in this lecture, this part of the video lecture, I try to only just provide the basic information about the virtual function, how it will work, how it will going to be declared, and how we can achieve polymorphism. In the next part of the video lecture, I'm going to discuss with respect to few examples where you get the clear idea how virtual function will help us to achieve polymorphism.